In this video, I'm going to go over lab number 2, the Isotope Lab. I'm going to run it for you, and you can watch me and then write down the data to complete your question section. So if you have not already gone through the introduction and done the pre-lab questions, you need to stop the video here, go do those things. You need to read the intro, answer the 3 pre-lab questions before watching this video. So let's get into the procedure. I'm going to read the steps as I go. So if you want to follow along, you can. For my materials, before I even start, I have my lab printed out. I have a balance, an electronic, there we go, balance here. I have a Dixie cup that I'm going to use. I'm going to put it on the balance to put my isotopes in. Otherwise, they will go everywhere. And I also have a bag of mixed beans. These beans are going to represent an element known as Bn. We are going to separate these out into the 3 different types and then find the mass of each so that we can calculate the average atomic mass for this element. Okay, so these are all of the atoms of the element Bn, holding them in my hands. So let's get started. So we are on step 1 of the procedure. If you are following along with me, we are going to start by sorting the atoms in my bag of element Bn into 3 isotope groups. We have isotope A, B, and C according to the bean type. Okay, so each type of bean is going to represent a different isotope, and each bean is going to represent 1 atom of that isotope. So I'm going to go ahead and dump these out. I just hope they don't go everywhere. Okay, and there are about 3 different kinds in here, so I'm just going to separate them into their little categories as best I can. Runaway beans. There we go. So for the purposes of making your data table, you are going to we're going to have to name these, which one is isotope A, which one is isotope B, and which one is C. So I'm going to say that this small group right here is going to be isotope A, this group here is going to be isotope B, and then this big group here is going to be isotope C. So for each of the 3 isotopes, if you look at the section of the lab that talks about the data table, you are going to need to count the number of atoms in each of the isotopes. We are going to find the total mass of the atoms for each isotope, and then you will be calculating the average mass and the percent abundance on your own. Okay, so I'm going to get started with isotope A. So let me move these other ones out of the way. That rhymed. You're welcome. So then I'm going to be going on to step 2 in the procedure if you're following along. So I'm going to count the number of atoms in my isotope A. I have 19 atoms in isotope A, so make sure that you write that down or put that into your data table. And then I'm on step 3. It says to measure the total mass of the Bn atoms belonging to each isotope group, and we are going to record the mass to the nearest 100th gram, and we are going to record this in your data table. So here is my balance. I'm going to put my Dixie cup on top. I'm going to zero this so that my Dixie cup, the mass of the Dixie cup, is not factored into the mass of my isotope A. Then I'm going to put all my isotope A atoms into my cup. .35 is going to be the total mass of the atoms for isotope A, so that should go into your data table. All right, I'm going to do isotope B next. This is my isotope B. I'm going to start by counting them. 43, we have 43 atoms of isotope B, so make sure you write that down. And then we are going to put these onto my balance. Let me put my Dixie cup on. It's zeroed, so it is good to go. I'm going to put in my isotope B atoms. Now remember that these are all of the atoms for the element. Okay, so the mass of isotope B, 9.93, we're going to go with 9.93. I'm making the final decision. So that's the mass of all the elements or all the atoms in isotope B. Finally, we are going to do isotope C. That's my biggest one. Oh, goodness gracious. I'm going to count them first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, I think I messed up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20, 21, 22, 23, 24, 25. 96, 97, 98. I hope I counted that right. Oh well, it's close enough. All right, so now I'm going to find the mass of all of my isotope C atoms. So I'm going to put my Dixie cup on my balance. I'm going to zero this off so that that weight is not counted, or that mass, I'm sorry. And then I'm going to put all my isotope C atoms into my cup. Slowly but surely. .72 is going to be the mass of all of my isotope C atoms. Okay, so you should have the number of atoms and the total mass of atoms for all 3 isotopes in your data table from this video. The next thing you're going to do is follow step 4, and you are going to determine the average mass of each isotope to 3 decimal places and record it in your table. The way that you do this, it gives you the equation right on the sheet here, is you're going to take the total mass of that isotope divided by the number of atoms of that isotope that you have, okay? And then that's going to be the average mass of each isotope, okay? And you're going to round that to 3 decimal places. Then you are going to add together all of the numbers of atoms that I counted up. So it's the 99 plus the 19, or the 98 plus the 19 plus the 43 to get the total number of atoms that I had in my bag to start with. And then you are going to start to calculate the percent abundance of each isotope. So to do that, you are going to take the number of atoms for that isotope divided by the total number of atoms. And you are going to record that percent abundance in your data table for all 3 isotopes. Once you have all that data in your data table, you should be able to go on and answer all of the questions. You will be using a lot of that information for question number 4, where you will plug it into the atomic mass equation to find the actual average atomic mass for my element Bn. Okay, so I'm going to show you the calculations that you have to do on your own for each of the 3 isotopes before you get into the questions for the lab. So I'm going to do the calculations for isotope A. If you want to put these into your table, you will do very similar calculations. You'll just be using different numbers for isotope B and isotope C. So for isotope A, we counted the number of atoms to be 19, and we also found the total mass of those 19 atoms to be 6.35 grams. The next step is to calculate the average mass of one isotope A atom, and I completely did not put the E on isotope. So to find the average mass of one singular isotope A atom, we are going to take the total mass of our 19 isotope atoms, which was 6.35 grams, divided by the number of atoms that were in that, or that were measured to get this mass. So 6.35 grams divided by the 19 atoms that made that mass up will get us an average mass per atom of 0.334 grams per atom of isotope A. And it says in the procedure that you want this to 3 decimal points, so I went to 3 decimal points with 0.334. So this is the average mass of a singular atom of isotope A. This mass, you are going to plug in to your average atomic mass calculation as the mass for one of your isotopes. And then whenever you get for isotope B, we'll go in for your second mass. And then whatever you get for isotope C, isotope C will go in for your mass number 3. Okay, so that's where this number goes. The next thing you need to calculate is the percent abundance of each of the isotopes. To do that, you are going to take the number of atoms in the isotope that you are looking at. So we are looking at isotope A. We know there's 19 atoms of isotope A. We're going to take that divided by the total number of atoms of the element Bn. So we are going to divide that by the total number of beans that were in my starting bag. Because that bag contained every single atom of element Bn. So I added up 19 atoms for isotope A, 43 for isotope B, 98 for isotope C, for a total of 160 atoms of element Bn total. So 19 atoms of isotope A divided by 160 atoms total of element Bn will get you 0.11875. Now this is a decimal, not a percentage. So to turn it into a percentage, you just multiply it by 100. And we are actually going to keep all of the decimal points for our percentage, as many as your calculator will provide you with, because these are both exact numbers. Remember, when you count something, like we counted 19 atoms, and we technically counted out the total of 160 atoms, those are exact numbers, so we don't count those when we're looking at sig figs. So just keep all the decimals. So when we multiply this by 100, you get 11.875%. So that's the percent abundance for isotope A. You will have to do the same exact thing, replacing this top number with however many number of atoms for isotope B and also for isotope C to find the percent abundance for both of those. And then you're going to use that number here for the percent abundance for your isotope 1, along with that mass we calculated. And then you'll use the percent abundance for isotope B, along with that mass, and then the percent abundance of isotope C and that mass. Okay, so that's how you do the calculations. you'll do these two calculations using the isotope B and C numbers. You're welcome.